Hello and welcome to our next installment of learning math by video. This is lesson 3.0. We're going to start off with our exponential and logarithms unit. And this unit's going to should be familiar to most of you guys because you've seen exponentials and logarithms last year. But we're going to rehash them all. I'm kind of trying to assume that you guys don't know too much coming into this class. And try to teach you all of the skills you need to be successful in calculus. And understanding exponent properties is one of those. So if it's been a while since you've done exponent properties, then this should be a good refresher for you. But we're going to do a lot of it kind of from scratch. Kind of just starting with the base assumptions of what does it mean to be an exponent, and then build off of that. What are the different rules that we have for multiplying two exponentials together? Okay, so let's dive right in. Okay, we'll start off with what the definition of an exponent is. So if x, which is going to be our base, is any real number, and a, which is the exponent, is some positive integer, then we define this notation, x raised to the a power, as multiplying x by itself a times. So you're, x times x times x if it's x cubed, x times x times x times x if it's x to the fourth, and so forth. And this makes sense when a is a positive whole number, right? If it's, 10, then it's just x times itself 10 times, okay? So for example, 2 to the fifth, that's 2 times 2 times 2 times 2 times 2. So you can break this down into smaller multiplication chunks if you need to build it all up. The first set of 2's is 4, and then we multiply 4 times 2, and that's going to get us 8. Then we multiply that by 2, and that's going to get us 16. And then we do the last times 2, and that ultimately gets us 32 as our answer. That's supposed to be a 1/6. Okay. And so from this you can see, you can just build the number up by multiplying it by itself over and over again until you get the answer. So a couple of important facts that arise from this definition. For example, if you raise 0 to any power, as long as a is a positive integer for now, remember we're assuming a is some whole number, so it could be 0 to the 5 or something like that, or 0 to the 10 power. And it's always going to be 0, because you multiply it by itself 0 times anything is 0, so we get 0 as a result. Okay, no matter what a is. Also, 1 raised to any power is going to give you 1 back, because multiply 1 by itself 10 times, or 100 times, or 1,000 times, you still get 1 as the answer. If you raise any number to the first power, x to the 1, then that gives you that number back. X is x to the 1. And so this is always true, just because multiplying a number by itself 1 time, that doesn't really mean anything. We're just going to say that's just giving you the number back, right? So 2 to the 1 is 2, and 5 to the 1 is 5, and so forth. And then a kind of trickier one is that what happens when you raise a negative 1 to a power? Well, it flips back and forth between positive and negative, depending on the number of times you multiply it. So if you have an even power for negative 1, you get a positive 1 answer. If you have an odd power for negative 1, you get a negative 1 answer. And so that should make sense, right? Negative 1 to the 6th power, you have negative 1, and then another negative 1, and then another negative 1, and you kind of see how many negatives there are at the end of the day. And each pair would give you a positive 1 out. So we can see our pairs here. Here's a pair, there's a pair, and there's a pair. Each one of those is 1, and 1 times itself 3 times is going to get you 1 out. And if you had an odd power for negative 1, then you'd get a negative 1 answer, because there'd be 1 negative 1 left over, so you'd always end up multiplying by negative 1. Okay, so those are some basic exponent properties that arise just from this definition, and trying a couple of numbers for x and a. All right, so here's the addition property for exponents. if you have a product of two exponentials, x to the a times x to the b, and so you multiply those together, then what you can do is combine that into one exponential with the sum a plus b as your exponent. So, and this only works if those bases are the same. If the bases aren't the same, then you find that you can't actually combine them together nicely the way you can if they are the same base. And you might ask the question, well, why is this true? Why is it that when we multiply x to the a and x to the b, we get x to the a plus b? Well, this is the diagram you should kind of think in your head. X to the a is x times x times x times x, and well, it's just a x's, right? And if a was 5, we'd have 5 x's, and if it was 10, we'd have 10 x's. So there's a bunch of x's all together, right, like that, multiplying each other. And there's a of them precisely. And then x to the b, there's b x's now, right? So we have x times x times x times x, and there's b of them. So if b was 7, you'd have x times itself 7 times, so it would be 7 x's. And so what you end up getting is a plus b x's, right? This one's going to give us a x's, this is going to give us b x's, and if we were to just remove those parentheses and count up all of the x's, there'd be a and then b, and so there'd be a plus b of them, right? And that should make sense, right? You know, if we put in some test numbers here for a and b, x squared and x cubed, well, that's going to give you x to the 5th. And why is that the case? Well, let's break it down. X squared is equal to x times x, and then x cubed is equal to x times x times x. And so we remove those parentheses, and we can just count up how many x's there are. You know, the x squared is going to give us 2 of them, so there's 2 here, and then the x cubed is going to give us 3 of them. There's 3 here, and so we end up with 5 total x's at the end of the day. You add them all up. So to find that answer more succinctly, we just use this rule, the addition property of exponents, where you multiply 2 exponents, you add their exponents together. Okay? As long as they have the same base. Now, it doesn't work if they have different bases. For example, 2 squared times 3 cubed. You can't turn this into 6 to the 5, so this is not equal to 6 to the 5 or something like that, where you multiply their bases and then add the exponents. So that's not true. You know, clearly this is 4 times 27. If you were to multiply those together, you get a number, and 6 to the 5 is way bigger than 4 times 27. So it's not true this way. And it's not 2 to the 5th because we're multiplying by 3. And it's not 3 to the 5th because we're multiplying this thing by 2. And so you can see that that doesn't work if the bases are different. Okay, multiplication property is our next one we're going to look at. X to the a to the b. So we multiply x, we raise the answer, x to the a, which is the exponent, to the b power again. Well, the way we can do that more succinctly is to just multiply those two powers together and raise x to that. So x to the a to the b is equal to x to the a times b. And why is that the case? Well, it has to do with some multiplication facts. So this is again what you want to have in your head. X to the a raised to the b power. Well, that says multiply x to the a by x to the a by x to the a by x to the a b times. So we're going to have b times x to the a times x to the a times x to the a times x to the a, right? So if you were to write all of these x's out, you know, this is going to give you a x's. This is x to the a. There's a x's here. This is x to the a. There's a x's here, and so forth. And so if you apply that addition property to each of those, you count up all the x's, you're going to find there's a times b x's. So you're going to have a times b of them. And this is because this is what it means to multiply. You know, if you were to have 3 times 5, this is 3 plus 3 plus 3 plus 3 plus 3. That's the definition of multiplication, is to add 3 5 times. And we're adding a b times in this case. So, for example, x to the 2 to the 3rd power, if we cube x squared, Well, that's the same as taking x to the 6th power. So x to the 2 times 3 would be, or x to the 6 is the answer. We can just write it all out. X squared cubed is, by definition, x squared times x squared times x squared. And so if you were to just remove all these parentheses and multiply it all out, you count up all the x's, there's 1, 2, 3, 4, 5, 6 x's, and so that would be x to the 6th power, okay? So some folks confuse this with other properties, and just remember, what does it mean to raise it to a power? And if you have to, write it all the way out the way we did, the way I did here, okay? And then it should remind you that the practice is, the rule is to multiply the exponents together, 2 times 3. Okay, it's subtraction property. This is our next one. X to the a over x to the b is equal to x to the a minus b, so long as the base x is not 0. This is so that the denominator is not 0. What is 0 over 0 anyway, right? We found out that that can mean a whole lot of things. A whole lot of things. Okay, so x to the a over x to the b equals x to the a minus b. Well, why is that the case? Again, this is what you should have in your head of what the definitions are. X to the a is x times itself a times, divided by x to the b, which is x times itself b times. And so you have you have ax's on top, and you have bx's on bottom, and so that means you're going to cancel bx's from the top. So you're subtracting off that number of x's. So you get a minus bx's as the result. So for example, here's x to the 6th divided by x squared. Well, that's going to get you x to the 6 minus 2 as the result, which is x to the 4th power. And why is that the case? Well, we write it all the way out. X to the 6th is x times itself 6 times. This is x to the 6th. And x squared is x times itself twice. And so from this we can see that there's 1x here that can cancel with that x, 1x on the bottom that can cancel with that x. And what you're left with is these 4 x's over 1. So that's just x times itself 4 times. So this is our exponent property for subtraction. Okay, diving right along. Exponent property is the next one. Zero exponent property. So what is the exponent x to the 0? What is that going to give you if you raise a number to the 0 power? Well, the answer to that is surprisingly not 0. It is actually equal to 1. And the reason why it's equal to 1 is so that everything works out nicely. And this kind of falls out from some of the definitions that we've already come up with from the properties from earlier. So again, this rule only makes sense if x is not 0. As soon as you put 0 in and you say, what's 0 to the 0 power? Well, things get really weird, and it's like, well, is it 0 or is it 1? And, you know, it feels like it could be either, so sometimes people take 0 to the 0 to mean one thing, and sometimes they take it to mean something else. But it's not well defined the way x to the 0, not 0. So why is x to the 0 to the equal to 1? Well, x to the 0 is equal to x to the a minus a. No matter what a is. A could be 5 or 2. Well, because 5 minus 5 is 0. 2 minus 2 is 0. And so you're, okay, all right. So you get the picture. It's equal to x to the a minus a. No matter what a is, right? Because then we get 0 in that exponent, okay? So this is because that, you know, those are equal. A minus a equals 0. Okay, and from earlier, our subtraction property was written this way: x to the a over x to the b equals x to the a minus b. But we can go the other direction. Here we can see we've got a difference in our exponent, so we can work our way backwards and write the fraction out. And when a and b are the same, then we get this expression right here. We get that equality. X to the a minus a is equal to x to the a over x to the a. And ultimately, what does that equal? Well, any number, x to the a, divided by itself is equal to 1. 5 divided by 5 is 1. 10 divided by 10 is 1. They're all equal to 1. So x to the 0 equals 1. And that's so that everything else ends up working nicely. And it turns out this makes sense for other properties as well. Like, you know, if you were to do x to the 0 to the a power, well, the product rule says that this is equal to x to the 0 times a. And when you multiply a and 0, you get 0 out. So it's equal to x to the 0, right? And that makes sense. This would be equal to 1, because we're saying 1 to the a power, 1 raised to any power is equal to 1, and that's true, right? So it makes sense that that x to the 0 is equal to 1, okay? Because if you were to do this property as well, you would get. All right, this is one that a lot of students will confuse, the negative exponent property. X to the minus a, if you raise an exponent, raise something to the negative a power, then that's equal to taking its reciprocal and raising it to the a power. So, and that only works as long as x is non-zero. Again, for the same reason, we don't want 0 in our denominator. That would be undefined. So, but for any other real number, that number to a negative exponent is going to get you 1 over x to the a. Okay, now why is that the case? Well, let's go ahead and use our rules we've already come up with. So I'm going to say, well, we know that x to the a times x to the minus a is equal to x to the a plus negative a. This is from our first rule. This is the addition rule. And just a minute ago, we figured out what that was. A plus negative a plus negative a, that's equal to 0. And we just determined x to the 0 was equal to 1. And so that gives us this equality here, that x to the a times x to the negative a is equal to 1, right there. And so now we simply divide both sides by x to the a, divide by x to the a, divide by x to the a, and you get the result, x to the negative a equals 1 over. And that's true as long as x is non-zero. And let's see why this makes sense. Does it fit in with our other rules, our other properties? This is where we kind of came up with that idea. But if we were to say we were to do x to the minus 2, and we were to raise it to the negative 1 power, then if we did this exponent property, we should get x to the second power, because negative 1 times negative 2 is 2. And so thinking about this another way, we think about this as 1 over x squared to the negative 1 power. Hopefully this is equal to x squared. And then when we raise this to the negative 1 power, we say take its reciprocal. And the reciprocal of 1 over x squared is x squared. So this is going to get us x squared as well. And so that also works if we use our definition and we use the product rule, and so that it's consistent, which is really good. That's what we want to see, is that it doesn't break all of a sudden when we try to apply one of these other rules that we have, like the product rule or the addition rule or the subtraction rule and so forth. Okay? All right, so a couple of just basic examples. You know, x to the minus 1 is equal to 1 over x. X to the minus 2 is 1 over x squared. And this is really important, is that a negative exponent does not guarantee that the answer is negative. So this doesn't mean the answer is negative, it just says that the exponent is negative, okay? And it says take the reciprocal and change it to a positive power. So if you're raising it to the negative 5 power, you take its reciprocal, 1 over that, and then you raise it to the 5th power. And to further add on to this, if x is ever positive, if x is a positive number, then x to the negative a will always be a positive number, because you're multiplying a positive number by itself a positive number of times, or a number of times, you can't get a negative as a result. So for example, 2 to the minus 4, right here, this isn't a negative answer, it's a positive answer, it's a small fraction. It's 1 over 2 to the 4th power by this property. And 1 over 2 to the 4th is 1 over 16, okay? And that's not a negative number, that's a positive number, okay? So this is always true if the base is positive. And if the base is negative, then, you know, it could be negative or it could be positive depending on whether a is an even or odd number. Okay. We'll do 1 or 2 more exponent properties and then we'll call it good for this lesson. Alright, so now let's look at some properties that involve 2 different numbers, not just x not just the base x. Suppose we've got the base is x and y. So what if we have a product, x times y, we raise it to the a power, to some power? Well, that's equal to x to the a times y to the a. So we can kind of pull that product apart. We can tease it apart into 2 pieces. Rather than x times y to the a power, we could raise x to the a by itself, y to the a by itself, multiply those answers together and get the result. So this is a totally fine thing to do, and I'd encourage you to investigate why this is true. Similarly, if you have a quotient, x divided by a, and you raise it to the a power, you can also raise each part to the a power, the numerator and the denominator, as long as the denominator is not 0, and you get the same result, okay? So if you have a fraction divided by, to the a power, to any power, you can just multiply the numerator by itself a times and the denominator by itself a times, and then take your quotient. And it just comes down to kind of the multiplication rule that you can multiply in whatever order you choose. So I want you to justify for yourself why both of the above properties are true, using the definition of what an exponent means, and some rules for multiplication, namely the associative property, and the commutative property. The associative property is a times b times c equals a times b times c. It means that you can associate a product. You can do a times b first and then multiply the result by c, or you can do b times c first and multiply the result by a. And then the commutative property says that you can do the product in any order. B times a times b is b times a. So you can change the order that you multiply things in and everything is fine. If you know these 2 rules, then you can justify, and the definition for exponent, then you can justify both of those above. Alright, we'll do 2 quick exercises and then call it good. Show that in general, x plus y to the a power is not equal to x to the a plus y to the a by finding a counterexample. Okay, go ahead and give this a try yourself, and then you can play the video and I'll show you the answer. So the answer is pick 2 values for x and y and a value for a, and see that they're not equal, right? So simply I picked 1 and 2, and for x and y, and 2 for a. And I found, 1 plus 2 squared, that's 3 squared, which is 9. I squared each of them independently. I did the right-hand side, 1 squared plus 2 squared, and I got 1 plus 4, and that's 5. And clearly 9 is not 5, and so they're not equal to each other in general. And this should drive home the fact that you can't bring that exponent down into the sum, right? If you have x plus 1, x plus 1 squared, that's not equal to x squared plus 1. Okay? You can't do that in general. Okay, second exercise. Show that in general, x to the a plus x to the b is not equal to x to the a plus b by finding a counterexample. Again, all I want you to do is show that, this doesn't work for one case, so it shouldn't work in general. So if you're trying to simplify, this would not be a valid simplification. Okay, so go ahead and give this a try, and then we'll look at the answer together. Okay, so suppose x is 2, and a is 1, and b is 2. I just kind of picked these numbers at random. I kept them small so they're easy to work with. So the first one on the left-hand side, we raise 2 to the 1 and 2 to the 2. That's going to get us 2 and 4, right? 2 to the 1 is 2, 2 to the 2 is 4, and so we get 6. The right-hand side, I need to add 1 and 2 together first. So that'd be 2 to the 1 plus 2, and that's 2 to the 3rd power, which is 8. Clearly, 6 is not 8. And so it doesn't make sense for these to be equal to each other. It doesn't make sense for these to the left-hand side, which is a sum, x to the a plus x to the b, and the right-hand side, which in fact equals x to the a times x to the b. This is a product of x to the a and x to the b. How often would it be the case where you took two numbers and you added them together, and the same answer you got out as if you took the same two numbers and you multiplied them together? There's not too many numbers where that works, you know, 2 and 2, right? If you add 2 and 2 together, you get 4, and if you multiply 2 and 2 together, you get 4. But in general, it doesn't make sense, you know. If, yeah, it's rare where you would get the sum of two numbers equal to the product. Okay, we'll hold off on radicals in this video, and because this video is already long enough, and we'll tackle radicals in the next one. Which radicals are really just, you know, x to the an exponent in disguise. Is guess what I'll have to say about that. So next video we'll talk about radicals, and hopefully this was enough. And I'll see you guys on Monday.